Now my bench light's in the way now. Move that over there. I don't expect there to be an awful lot in this. Just a power supply and an amp. Let's have a look. The input of the power supply is over here, and I can see a resistor there, which looks a little bit dark, but it doesn't look blown out or anything. These here will be the switching transistors for the power supply, and the output side is over here. So this is the amplifier board here. The volts out of the power supply will go into there. So these things here are likely to be the dual diodes that provide all that nice current that an amplifier needs. The first thing we're going to do, I think, is probably just check those presumed Mosfets over here and just see if they're short circuit, because when Mosfets fail, they always fail short. And let's get this tested. One of my probes is broken. Not really sure how that happened, but it won't affect testing this. Let's have a look. Oh, that's very short circuit. Okay. And so is that one. Let's take these off the boards and get them tested out of circuit. Let's take this out. Because we really need to get this board out for further testing anyway. These Mosfets and these things work so hard. Switching the mains off thousands of times a second. It's a wonder they last as long as they do. Really nice modular design. I like that. Makes it nice and easy to service. See if we can get this off. There we go. Lovely. So this board here is just the amplifier board. You can see the 2 amps just attached to there. They'll be like TDA something or others. Usual sort of thing. Just having difficulty sucking the solder past them. Oh, that looks a little bit better. Let's maybe redo these ones. I might redo the solder on those and then resuck it back out again. That looks better. Yep, that looks pretty good. I think we can take them off. Hopefully we can just wiggle. There's nothing else on the heatsink. No, that looks all right. We can just wiggle that off, all being well. There we go. Famous last words. Well, that one's off. IRF 740s by the looks of it. Nice standard Mosfet. I think I might have an equivalent to that somewhere. Some nice little touches in this base box. I like using a bit of sort of thread lock just to hold that onto them, because it's very easy for those to fall off, and then yeah, that becomes a bit of a pain in the neck at that point. They don't like staying on sometimes. Let's see if we can loosen that middle pin on this one. Here we go. Let's test the pins, or the pads now, on there, and just see if they're still shorted. No. So that tells me that the switching controller chip is probably okay. And that's that chip there. When they go, yeah, they really tend to go, and they tend to popcorn. So the problem is more than likely just in those Mosfets. Let's test those. For that we use one of these, nice generic transistor tester off of eBay. I think this one was about £25 or something like that. Now, can I get it in the socket? That'd be nice. So you put it in there, press a button. Okay, it's gone into self-test mode, and the reason it's done that is because that's pretty much a dead short. So it thinks it wants you to calibrate it, basically. I think we can ignore that. Hopefully I can just turn that off. Not actually seen that before. Let me see if I can reset it. Oh dear. Let's skip that one and just test them both with a multimeter, because my transistor tester is a little bit upset now. It's gone into self-test, it doesn't want to come out. Yeah, that is not happy. Not happy at all. Let's have a look at these then a little bit further. That is an IRF 740 by the looks of it. Can be difficult to see under an iPad. And that looks like a 740 as well. Just going to double check that and then see if I've got an equivalent to them. And my go-to replacement MOSFETs are these. These are the 15N60Cs. They're higher rated than the RF 740s and should do the job very nicely. Also, they have insulated tabs, so I won't need those little insulators on there when I put them back on. Now, first thing we need to do is give the heatsink a bit of a clean, and for that we're going to use some isopropyl alcohol and just get rid of that heatsink paste and replace it. Spray a little bit of that on, put some on some blue cloth, just clean that all off. And then that will just fit on there like that. Let's put a bit more paste on. Now we only need a thin layer of paste on these. So we're just going to squeeze a little bit out, and that will be enough for both of them. That's one done. Don't need an awful lot. All you're doing is filling the microscopic gaps in between the back of the transistor and the heatsink. Let's screw those onto the heatsink now. Oh, this stuff is so messy. I have a love-hate relationship with heatsink paste. I think we all do. Okay. Put that in there. So we don't need to have the silicone pads, we don't need the insulating washers because these are plastic bodied, so we can just put them straight on. What I'll probably just do is put a very small dab of thread lock just on the top as well. These things are fiddly enough as it is, but they're even more fiddly when you're recording it at the same time. There are some real tubers out there that make it look so easy. And yeah, can certainly be interesting. So you won't do these up super tight just yet. You just want to get them on there. Need them reasonably straight. Want them to line up with the holes properly. Right, let's put that back on the board. There you go, back in that way. Like so. And we may as well screw that heatsink back on again as well. Now the important thing to note with these transistors, as I said before, is they must be at least, the technical electrical characteristics must be at least what the old ones were, and I always like to overrate Mosfets slightly anyway, especially for amps. They get a bit of a kicking with amps. That's all nice and tight there. Let's solder them back on again. This is so fiddly under an iPad. I need some magnification. My eyesight ain't what it once was. Yeah, there's a direct short across there now, which we need to get rid of. I'm going to put a little bit of flux on this. That can sometimes help separate joints that are kind of, yeah, a little bit stuck together. Or not. No, I'm actually going to desolder that. May as well do the M1 then. Hey. let's get this one done while we're down this end. That looks pretty good. Let's desolder those ones there. That looks better. Oh, for goodness sake. Maybe I should be using a smaller tip. I don't want to overheat these transistors, although they are pretty tough. I will measure their resistance afterwards just to make sure that nothing bad has happened to them. I'm going to blame this on soldering under an iPad. It's really bloody difficult. That looks good. Let's test that now. Let's make sure there's nothing gone short anywhere. Let's clip those leads off. As the leads fly everywhere. And we'll just brush. Brush a bit of the flux off as well. Can become conductive apparently. Right, let's see what the multimeter thinks about those FETs now. Good. Let's put it back in the box and turn it on. And normally when FETs go, they do seem to like taking each other out as well. I've seen that a few times before. I'm guessing it's quite a lumpy power supply if it's got 2 FETs and 2 output diodes. Must be pretty darn lumpy. Put the mains connector on there. And I do need to still screw up those Mosfets as well. I haven't forgotten. Let's get those FETs screws tightened back up again. Nice and tight. Not fiddly at all, obviously. Done. Let's get a new fuse put in its fuse holder. Might just be worth me measuring the resistance across there, see if it's something halfway sensible and not, you know, a few ohms kind of thing. Poor probes. Yep, that looks alright. 300 kiloohms and rising, probably because of the capacitors or current in rush, but that's fine. It's not ohms, and that's all I'm interested in. Now this fuse is a 1.6 amp. See if I've got something that'll fit that. And this will do very nicely for testing anyway. It's not quite right, but it's close enough, and I can order a new fuse on Monday for it. Let's put it back in its box and turn it on. Have we got a power light? Yes, we have. Excellent. We have a power indicator, so let's put it back in the Wharfdale box. Well, that didn't work. Yeah, it just blew the Mosfets again, which is really no fun. So we have it back again. I've already taken the Mosfets out, and I've had a bit of a further look at the chip that drives the power supply, and that's that chip there, and that's an IR2153 by Infineon, and that's driving the two Mosfets. Now Mosfets are weird things. You know, on the one hand they're very tough, and on the other hand they can easily be ruined by incorrect driver signals going into the gates of them, which is what switches them on and off. So I got to thinking that maybe this driver chip had also gone, and that's what was taking out the two Mosfets. So I've gone onto RS Online, got a couple of new Mosfets and a new driver chip, and I'm going to replace those. Now I'm definitely going to point out I'm not an expert at this sort of thing, I'm just a hobbyist where this sort of thing's concerned. But I do seem to have quite a lot of success fixing stuff, so hopefully this will be one of those things. One of those stuffs. Take this back off again. There's no short on the amplifier board here. I thought I'd check that, and that seems absolutely fine. So unless maybe this transformer is dead, I can't see what else could really be taking those FETs down. Let's take this off anyway. And they could have put the connector on the other way around, couldn't they? That would have made it easier to disconnect. But oh no. See if we can get this chip out. I think I'm going to put just a little bit of solder on there just to help it along its way. This will be manufactured with the lead-free solder. I always like to put just a little bit of extra solder on. It gives it a bit more thermal mass. Hopefully will make it easier to desolder. I could have just cut it out, to be honest, but I like using my desoldering gun. Although it can be a bit hit and miss. Still better than one of those solder suckers. Okay, let's have a look. Should be able to lever that out now. A dental pick can be very good for this sort of thing. And that is that out. I can't see any actual physical damage to it or anything. Let's get it replaced anyway. It's definitely in the right way. Wouldn't want to put that in the wrong way. Hey. Let's get a little bit of solder on the end there. If we put it on the corners, it will hold the chip in while we're soldering it. There we go. Now we can do the rest. They look okay. I'm just going to check under a magnifier. Yep, they're fine. Put that to one side, and now we need to replace the Mosfets on the heatsink. There you go on there. I'm going to go and get some heatsink paste. Heatsink paste acquired. Now, where are these going to go down to? That way. Doesn't have to be neat. Put that one on there. And that will insulate the metal back. That one on there. Then we need a little bit more paste on the transistor. Put just a little bit on those. Don't need much at all. It can go on there. It can go on there. These then go on there. Now, I'm not sure where those washers go. I'm going to put the washers after the bolt, I think. It's just a case of screwing them on. Oh, heatsink paste is disgusting. Gets everywhere. I mean, necessary evil, unfortunately. That should do very nicely. I'm going to give these a further tighten up because I want them to be nice and tight on there. Don't want them vibrating loose. Perfect. Let's put this back on the board then. There we go. And put these in because it will hold that in place when I solder those leads up, which they were a pain in the arse to solder last time. Perfect. Let's get these soldered up. They look much better than the last time. The first time round, again I'm just going to check those under some magnifiers. They look good. And just to be on the safe side, I'm going to test it with continuity on a multimeter. Perfect. It all looks pretty good to me. Yeah, it looks excellent. Let's put it back in the speaker and see what it does. I'm going to put the other 2 screws in for testing. No point creating extra work for myself. Need to replace a fuse in this as well. And let's replace the fuse. Let's get a fuse in there. We can actually quite easily just plug it in like that and see if we get a pilot light on it. Although I think I prefer the safety of it being in its box, in its enclosure. Well, this is a moment of truth, whether this pilot light comes on or not. Awesome! Let's see if it's actually generating noise. Oh yeah. Well, that's fixed then. Time to take it apart, put those screws back in that's missing, and that's done. If you enjoyed this video, please like and subscribe, and thank you very much for watching. Good night.